simply removing a burnt MOSFET on GPU is not a proper repair. The card may even work just fine, but in fact it won't last long. One of the remaining MOSFETs will die sooner or later for sure. In this video I'll show you how to prevent that and what the proper way is. Hey, you're watching the ForterFix channel. I repair graphics cards, gaming consoles and other stuff too. In some cases, a shorted MOSFET leaves a hole in the PCB, so it's no longer possible to use the same place. It's good if we have some unused spots, where we could install a new MOSFET and move related components. But that's not always the case, and of course it still requires some rewiring. So here is a 1080 Ti board from Gigabyte. We can see there is a burnt driver MOSFET on the NVVDD rail. It's clearly welded to the pads. Let's grind it off and see what can be done. Well, obviously this spot cannot be reused, and we don't have any unused places on this board. By the way, the board is already working right now. I know a lot of people would just leave it as is, but that's wrong. If one of the spark plugs in your car engine suddenly stops working, your car will still run, but you'll definitely feel that something is wrong. The engine becomes disbalanced, fuel distribution goes haywire, and if you push your engine to the limit, it won't last long. It's exactly the same with GPUs. The controller keeps sending signals to the missing phase. Because it sees zero current from that phase, it keeps increasing its duty cycle, while reducing it on the good ones. As a result, the remaining phases get uneven workloads. The total power measurement becomes inaccurate, so the voltage becomes unstable. Your card may boot and work at low load, but under gaming or stress it will have voltage drops, voltage noise and extra heat on the remaining phases. It can crash, throttle and simply won't last long. What we want to do is to reduce the number of phases the PWM controller tries to use. There are some controllers like MPS with their own firmware where it gets tricky, so let's leave those for another video. But in the vast majority of cases, we're dealing with some UP and CP or similar chips. The number of active phases on these controllers is usually defined by setting a strap. On this 1080 Ti board, we have a UP9511P PWM controller. To set the number of phases, we should pull up the corresponding I-send pin to 5V rail using a 100K resistor. For example, in order to have 7 phases instead of 8, we should pull up the I-send 8 pin. Usually, boards already have places for these resistors. They might just not be populated. But there's one major caveat. That strap doesn't only mark the phase as disabled. It actually defines the first disabled phase, and all phases after it will also be disabled. In this case, our damaged phase is number 4. If we put the resistor on I-send 4 pin, we would only get 3 working phases, because everything from phase 4 onward gets disabled. So what should we do? It's actually pretty simple. We disable phase 8, but at the same time we rewire the PWM and I-send signals from our missing phase 4 to the actual phase 8 components. The PWM controller will think it's driving phase 4, while in reality the signals go to and come from phase 8. We should also remove any connections to feedback circuits from the missing phase to avoid any unwanted interference. Now the PWM controller is set up to work with 7 phases, which is the correct number in our case. Keep in mind though, Removing phases has one downside. The card will still try to reach the power limit hard-coded in its BIOS, but with fewer phases, this results in higher current through the remaining phases to compensate. In this case, we lost one of 8 phases. That's a 12.5% of current capacity. We cannot modify the power limit in card's BIOS, so the only safe option is to use tools like MSI Afterburner to lower the power limit. Yes, we will lose some performance, but that's the only safe solution aside from swapping the core and memory onto another board. By the way, speaking of PWM controllers, do you know that just one extra capacitor in feedback circuit may turn your controller into a time-ticking bomb for MOSFETs? Oh yeah! Check this video about the factory error on some gigabyte cards for more details.